So, continuing on, derivatives of logs and exponents, we're going to look at y equals x to the x. This doesn't fit the rule because the rule says it's for y equals a to the x, where a is some number. And so this is a problem because we have a variable raised to another variable. We don't have any rule for that, right? So we're going to have to do implicit differentiation on this. All right, so that means we're going to be taking the derivative of the y and then also the derivative of the right side. And for us to take something that's in exponential form and get it out of exponential form, we have to make it a log. We have to do something with logs, okay? So you have two options. You can write the word log on both sides, so you can log both sides, or you can ln both sides, okay? So I'm going to write out both of those to start with. We can say that we've got log y equals log x to the x, or we can say ln y equals ln x to the x. And most of us would be a little bit lazy, and ln actually has easier derivatives to work with because it's just 1 over x as opposed to the 1 over a times ln x, right? It's a little bit easier. So most of us would say, well, both of these are valid options. I'm probably always going to do this option because I like to be lazy if I can. Do you guys remember what you do with an exponent? You bring it to the front. Yeah, so this is basically ln y equals x times ln x. So I rewrote the problem. I made it so I no longer have a variable raised to a variable. I made it so it's easier to work with. So, do we know how to take the derivative of ln y? Yeah, so it's 1 over y and then dy dx. And then how do I do the derivative of x multiplied by ln x? Product rule. So I've got the first multiplied by the derivative of the second, 1 over x, plus the second multiplied by the derivative of the first, 1. So at this point, if I clean this up a little bit, I have 1 over y dy dx equals, what happens with this part? Those cancel, right? 1, or x times 1 over x is just 1. So I get 1 plus ln x, right? I don't know why I wrote that through the line. I'm sorry. Okay, so 1 plus ln x. And then how do we get dy dx all by itself? Multiply by the y, right? We just want to bring that y over to the other side, so I'm going to say multiply by y. Take this entire side and multiply by y. And if you guys remember when we did the implicit differentiation, every so often we would make like a substitution. If we knew what something equaled, we would take that thing that it equaled and we put it back in the problem. Do we know what y equals? It equals x to the x. So I'm going to say dy dx equals 1 plus ln x, and we're multiplying it by y, except we know from the very original problem that y equals x to the x. So over here, instead of me writing y, I'm going to write x to the x, and that's good. That's my final answer. This is the derivative of x to the x. Okay, we're going to do another one, same process. And these problems right here are similar to the last 3 problems on your book assignment. So for those of you back there who are complaining, you couldn't have done the last 3 problems anyway because this is how you do it. So I got you. You're good. Okay. And then the rest of you, when you guys get to them, you'll know how to do them. So
the last
The last three, those were the ones you hadn't gotten to yet. Okay, so here is the other example we're going to do. Again, we don't have a rule for this. There's no shortcut for how to take a trig function that's raised to an exponent that's a variable. That's not a thing that we've learned how to do. We could do it if it was sine x squared. We know how to do that. But sine x to the x, we don't know how to do. So again, we're going to ln both sides. We could log both sides. It just makes a more difficult derivative. You know, it makes it a little bit more complicated, so we might as well be a little lazy. So I'm going to say ln y equals ln of sine x to the x. And what should I do with my exponent? Bring it to the front. So what is the derivative of ln y? 1 over y, and then what else? dy dx. And then how do I do the derivative of x multiplied by ln of sine x? Product rule and chain rule. Yeah. So I've got the first times the derivative of the second. So what's the derivative of ln of sine x? 1 over sine x. So that's the outside function. What's the derivative of the inside function? Cos x multiplied by cos x. Okay? So we did the first times the derivative of the second plus the second times the derivative of the first. So ln of sine x multiplied by, what's the derivative of the first? This one. Times 1. Alright, so I'm going to clean this up a bit. Does anyone know what cos over sine is? Cotangent. So you got x times cotangent x plus, and then we've got ln of sine x. Okay. So now what are we going to do? Multiply by the y. So dy dx equals x cotangent x plus ln of sine x. And instead of multiply by y, what should I put? Sine x to the x. Good. Whew. Crazy, right? Make sure you go home and show your parents. They'll be so impressed.